Okay, this would be how to do question like 16, normal form. First of all, this is A and B and C. And we need to figure out what the square root of A squared plus B squared is. And in this particular question, it would be square root of 4 plus 25, which is the square root of 29. Now, to get it in normal form, you take that value you just figured out, and you divide each term by that. So negative 2x divided by radical 29. And you use a use a negative radical 29 because there's a positive here. And the reason is because when you get to the normal, which is the p-value, you want that to be a minus sign. So plus 10 is not negative right now. To make it negative, we got to make it negative radical 29. So this is normal form. It could be cleaned up a little bit. 2x over radical 29 plus 5y over radical 29 plus, minus 10 over radical 29. So that's normal form. What is the length of the normal? It's the positive 10 over 29, which is a decimal value. The angle the normal makes with the positive x-axis, let me make a little bit of room on this paper. Take a picture, bring it over to another page. So I'm in normal form right now for letter B. Kumbaya. So I said 2x over radical 29 plus 5y over radical 29 minus 10 over radical 29. And we know that this is normal form because normal form says it's x cosine phi plus y cosine phi, y sine phi minus p equals 0. So you can see that p is that. To get the phi value, or if you call it theta, whatever you want to use, you want to do the cos, or the arc cosine, or the cos negative 1, or the inverse cos of the value in front of x, because that's equal to the cosine of that, so 2 over radical 29. And you can do the same thing with the sine, too. I mean, there's a different way to do this, but we'll do the same thing with the sine. And you should get the same value. And because we are, well, let me figure this out. I'm thinking too far ahead. Okay, so when we do that on the calculator, I'm going to get my calculator to turn on. Hold on. Again, you want to be in I keep saying that. You want to be in degrees, not radians, for this type of question. So make sure you're in degrees. And then I keep doing this again. Second cos of 2 divided by radical 29 is 68.19 degrees. 68.19, did I say? 1985 degrees. Okay, so it's about a 68 degree angle, theta. Now, why do I know it's positive 68 degrees? Because my cosine is positive and my sine is positive. If they're both positive, you're in the first quadrant. If one was negative and the other one was positive, for instance, if sine was negative and cosine was positive, this would be a 68 degree reference angle in the fourth quadrant, but that's not the case here. Sine and cosine are positive, so you're in the first quadrant where they're both positive. So you're good with a 68 degree angle there. So theta is 68 degrees. And when you draw it on your graph paper, you'll see it's like a 68 degree angle. Okay, now graph the line in each component of A, B, and C. So you know how to graph this just by regular means. So we're going to go back to our graph paper. I mean, this one's nice and easy. If I let x equals 0, then y is 2. If I bring the 10 over, it's negative 10. Y is 2. If y is 0, then x is going to be 5. So I kind of made it easy. Okay, so on your graph paper, you would graph this. And you got to, well, you have to be, well, try to be careful. X is 0, y is 2 is here, and x is 5, y is 0, 1, 2, 3 is here. So you graph the line, which is very elementary. Obviously, make sure it's straight and connecting the dots. You'll have a straight edge for the final. And then on your paper, draw the normal, which would be the angle that makes a 90-degree angle with the line itself. So I want a perpendicular angle. It's not a very good one, but I want a perpendicular angle from the origin. So obviously you can't do this on the test, but you can get a good idea where it's perpendicular, which is right about there. And now that makes sense to me because I have a right angle here, and this degree measurement is past 45. It looks like it's a 68-degree angle here. Okay, so you have to mark that, and you have to write. You would write P equals what was it? 9 over 29. Anybody? What was P? 10 over 29? 10 over 29. So that's that. So this is the line, and that's the normal, and that's the phi, or the angle the normal makes with the x-axis. Again, you got to embellish this, clean it up a little bit. Negative 2x minus 5y plus 10 equals 0. So when you graph the line, that should reaffirm that you did the normal. You found the normal right and the degree right. Theoretically, I could go on my calculator and do 2 divided by second square root 29 is 0.37. I'm sorry, it's not 2, it's 10. 10 divided by second radical 29 is 1.85. So theoretically, if I zoom in, I mean, not theoretical. Well, I guess it is theoretically. If I zoom in here to this point, it should be about 1.85 units long. So if I take my pen and I overwrite on this, again, this isn't purely accurate, and then I bring it over here and rotate it down, and I didn't draw it very well. Looks like I need to shrink it down a little bit. Okay, so this is about 1.85, let's call it. So if I come up here and connect it here, again, we're out of scale. I didn't draw it perfectly straight. So it's about, that's about accurate, 1.85 units long. So that's what all that information means. So we'll end the video here. This is just one question, normal form. Have to show the work, have to show you understand what's going on here, and graph it nicely. And that's all I have to say about that for us. God bless you.